Hey everyone, welcome to Ford Country Outdoors. This is going to be part of my new segment we're doing. It's going to be called Broke White Boy. This is what you got to do when you're broke, and so is your stuff. We got us some Gorilla Glue sticks here. Got us a little glue gun. Got high and low on it. Now what we've done is I needed a 4-cell battery pack, lithium ion battery pack, to repair a 13-cell pack. And I had this Milwaukee battery that had a bad cell in it. So I tore it apart, and it contained these green cells that you see here. And I individually charged and tested each one of the cells to get me 4 good cells out of it. Now these are really good cells. They're Samsung 18650 25R cells. And they actually match. This is what come out of the 13 pack of cells out of the battery I have to repair. And so after pulling it apart, finding out the good number of cells that I had, I used a remote control car charger to individually charge them, and then I tested them, and then I loaded them using a 12-volt incandescent bulb to make sure. And there it is right there. It's a car bulb, 12 volt. It actually has the resistance in it. So I used it to test the batteries to see the rate of discharge they had, and I found 4 that I want to use to repair this battery pack, and I'll show you the pack. This is the pack that I'm repairing. Like I said, it's 13 sets of 4 batteries in here. And what that does in having the 4 sets, each one of these batteries have roughly 3.8 volts. So when you wire them in parallel, you keep your 3.8 volts, but you keep increasing your amp. So if each one of them is 2800 milliamps, then that's, you're adding 2800 more, 2800 more, 2800 more to reach the amperage that you're looking for. And then after you get each cell pack of 4 done, wired in parallel, you then take and start wiring those packs in series, and that increases your voltage. So what we're looking for is a 10 amp hour 48 volt battery pack. And as I said, it has 1 pack that's down. So what was happening is it was causing the entire system not to charge. So we're beginning with gluing these in a set of 4. Glue stick. It's got this glue gun, and evidently you got to have the long sticks, and I got the short sticks. Put out a kickstand, push the glue down in there. They're all leveled up, and there we go. Alright, so we got those 2 glued together. Now we got to add the other 2. And I'll be right back. Alright, now we're going to take the other two of the 4-cell pack we're making and glue them together. Like so. And once we get them glued together, we're going to take our two that we glued together, and then glue those together. Just like so. We'll unplug our glue gun because we won't need it for a while. Well, that Gorilla Glue is pretty good. Alright, now if you'll notice, if you can see here, we got all the negatives on one side, all the positives on one side, and that's going to be our 4-cell pack. That will be at 3.8 volts. Fully charged, it hits 4.4. So those are stuck together nice and well. Now since these are batteries that I'm reclaiming, I will have to clean up the tops of them. And that's where we use these here micro cutters. And we'll clean up the top of them, and we'll also use this little diamond file. Can y'all see that? Probably not. We'll use this diamond file to make sure they're smooth. And once we get them smooth, we can weld our nickel on top and join these batteries together. Now if your little diamond file don't get the job done fast enough for you, you can use a Dremel with a small grinding stone. You don't want to stay in one place too long. You want to keep your little Dremel bit moving around so that you don't heat the battery up. But you do want them nice and smooth so when you start your spot welding, your nipple will be good and flat on there. Kind of move from battery to battery. Spend a little time on each one until you get them all where you need them. That way you don't heat up one battery too much. And once we're done with the Dremel, we can come back with our diamond file and polish it off. Now for the next stage of this project, we need to pull out our big nickel strips, and what we're going to do is we're going to start with the negative side, and we're going to spot weld these negative side of these batteries together. Start our cell. Now, once we've got our piece of nickel cut, we'll place that right on top of the battery. These particular strips, if you can see, have cutouts in there, and what that is designed to do is make the resistance run around so that you get a better weld. Now to spot weld these, we're going to be using our CC spot welder. So we'll turn it on by holding the power button down for a few seconds. It switched on. It's on gear 8 now. 21 degrees Celsius on a 1 second delay. And what that means, once it reads resistance in between these probes, it then begins to put some fire in the wire. So we're going to press down lightly on our first cell. And we're going to put a few welds on there. And we're going to go to our next cell and put a few welds on it. Again with the third cell. And one more time with the fourth. And that's what it looks like. I know the lighting's horrible. After you get them all welded on there, those are welded nice and tight. Spot welds look good. And we'll call that a done deal. Now we are going to put a couple of strips of this nickel on each side because this is 1.5 and the amount of amperage this battery is going to carry, we're going to need it a little stronger than that. These cutters are great, but they're not too good for cutting this thin nickel. Need some scissors. Let me pause this and get some scissors. Now after you get your nickel welded on there, it kind of looks like that. Hope y'all can see that. But that's the negative side and it's done. Now we're going to take a minute here and we're going to recheck our voltage on our batteries before we connect the other one, the other side, the positive side. And we're just going to do that just to make sure we didn't damage any of the batteries. So we got 4.4, 4.4, 4.4, and 4.4. So our battery's still in good shape. We can move on to connecting the top of the batteries, positive side. So we'll cut us another piece of this nickel. Like so. And we'll fashion it on top. Positive side of the battery. And then we'll weld it down. All right. Now with that done, again, we're going to check our voltage. And we still should have 4.4 on both sides. Because all we've done is increase the amperage. And we've got 4.4. So that's looking good. So with that done, we're going to add another strip of nickel to the top of this battery for good measure. And it should be able to handle all the amperage we need to get that bike scooting down the road. Alright, so there we go. We've got both sides of the battery connected, the negative side and the positive side. And we did it with 2 layers of 1.5 nickel, which gives us a total of 3. And I'm pretty confident all the amperage that we need for this 13S pack. Alright, now as you can see, we have, let me get some light on this up. We have welded our green pack that we built right here to this set of pink packs that was the original, and they're actually going from positive to negative, then positive to negative, and positive, negative, all the way down. And that's what creates our 48 volts. There's 13 of these packs that are wired together. So now I got to flip this over and then weld this pack here to this pack. And that completes our negative side. Alrighty. Okay, everybody, I've kind of fast forwarded to the finished product. Now the heat sink that I ordered for this battery did not come, so I've kind of fashioned the old one back on, and got the BMS reattached and resoldered. I put the charger on it, charged up fine, and turned off. And as you can see, we hit our mark, 52.5 volts out of the entire pack. So now all we got to do is put it back in the aluminum housing.